right, hello everyone. Today we are going to work with or learn about scientific notation, which is an extension of exponent and exponent laws and power. Let's do a review of exponent laws, and I'm going to use powers of tens. As you can see, it's a tricky question. Help you to learn a couple of new concepts, and then we can go right into scientific notation. So we want to simplify this. All right, we go through that. Notice that the only catch to this is that you cannot use a calculator. You have to do a freestyle. All right, so and then the last thing that we're going to do, the final answer will be in powers of 10. We're going to write down. All right, the first thing first, notice that the denominator is 20 times 30. And I don't want to use a calculator, so we need to kind of change that into powers of 10, and we can. So let's go through that and do that. So the top 10 squared times 10 to the power of 3, all of that to the power of 4, divided by, now instead of 20 we can write it at 2 times 10 because we're going to use the power of 10 times, and then 30 is 3 times 10. And all of that to the power of 2. All right. By the way, this is only one way of doing this. You could start tackling the top first, then manipulating the bottom, the denominator, and that's okay. But I rather do everything at once so that everything is written in the same format. Then we can go through and actually deal with the exponent laws. All right, so now that we have this, let's try to figure out, let's do the bed mass. Let's kind of compact, make the numerator compact. So 10 squared times 10 to the power of negative 3. We can do the bed mass, so bracket first. So that would be 10 to the power of, I'm adding the exponents, so it would be minus 1. And all of that to the power of 4. So the outside the 4, I haven't touched any of that. Just let that be for now. So the denominator now, I have 2 and 3 in the bottom. So let's do, and 2 and 3 we can do 6. We're multiplying them. Okay, times, and then that's 10. They're 10 to the power of 1, 10 to the power of 1, and that would be 10 to the power of 2, and all of that squared. Actually, let me change that to the blue. Squared. Excellent. Okay, last. Now we're going through the exponent laws. Let's deal with that. All right, so now we're going to incorporate the power of power law. So 10 to the power of minus 4. Remember, 4 times minus 1. That's how we're going to do that. Multiplying the exponents when you have a power of power law. Denominator, this 2 belongs to 6, and the exponent right here belongs to 6 and belongs to 10 squared. So that would be 6 squared times 10 to the power of 4. Great. All right. So now what are we going to do? Now we have to do the division. There's a base, same base, which is 10 and 10 we have. There is no 6 anywhere, so 6 will be in a denominator. So we're going to leave 6 squared in the denominator. But the numerator, we have a 10 to the power of negative 4, 10 to the 4. So basically when you're dividing, so I'm going to put in a side note here, side note. So 10 to the negative 4 divided by 10 to the 4. We do 10 to the negative 4 and then minus, because this division, you have to subtract the exponents having the same base. So that would be minus 4, negative 4 minus 4. And the final answer would be 10 to the negative 8. So, and 10 to the negative 8 is actually stays on top. So that would be 10 to the negative 8. Okay, and here is the thing with this is the side note right there. All right, that's how we got that, and that's what we got that. Now here's the final thing. We cannot leave our exponents in negative form, so we have to change that to positive. So if you remember, we have to bring that down. So the final answer to that would be 1 divided by 6 squared times 10 to the power of 8. And we are using the negative exponent law, which is, in this case, the negative exponent law will end up being, this is what we used, x to the negative n equals to 1 over x to the n, where x cannot be equal to 0. This is what we used to manipulate this. All right, now we're going to deal with scientific notation, and let's go through. I just wrote down some of the powers of 10 that you're familiar with: 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 1100, and then the negative exponents, so that you're having some familiarity with that. So let's just start off with the first thing. The first thing is that every number that you see, so let me give you an example. Every number that you see, it can be written in terms of a decimal form. So 2 could be written at 2.0. 10 could be written at 10.0. All right. So every time that you see, we need to be able to change it to the decimal, so that we can move the decimal place, this decimal point right there. We can move it, and based on the movement of that left or right, that would dictate what kind of a powers of 10 we're going to have. Okay, so these are the rules. I just decided to write it beforehand so that I can save time. So these 3 rules you have to follow every time for the scientific notation. So let's go through a couple of examples, and then we'll see what's happening with that. We can apply these rules. So let's suppose we're going to change 200 and let's say 200 into scientific notation. Well, there is a decimal out there, even though it's not written, but it is there. You can actually put it down, and then we want to change it to scientific notation. So it's very important that this is now being moved 1 to the first non-zero digit in front of it, and that would be, we will stop there. We will not move the decimal anymore, and then we write. So that would be 2.00 times 10 to the power of, now because we have moved it to the left, 1, 2, that would be 10 to the power of 2. And you really don't need to write the 2 zeros here. You can just put 2.010 is okay, and that's acceptable to make it compact, and that would be the answer to that. All right, so in this case, now we have 0.0032, and in this case we are moving the decimal to the right. So to the right, and we're moving it 1, 2, 3. We're going to stop right there because the first non-zero digit we have to stop. So we're going to write now 3.2 times 10 to the power of negative 3, because the decimal has been moved to the right. One more thing, in the scientific notation, the first number, these numbers, the very first number that shows up before the powers of 10, they must be less than 10 and greater than 1. All right, let's do one last question. Let's do C, and this one 235,000. Let's change that to scientific notation. All right, so quickly, we have the decimal right here. We're going to move it to the left. 1, 2, 3, 4, and 5. We will stop right there, the very first number. So that would be 2.35 times 10 to the power of 1, 2, 3, 4, 5. Positive 5.